Okay, let's look at the Pythagorean theorem and other similar results. All right. So if you have a triangle ABC with the right angle at the vertex C, then we have these equalities. All right. First one is a squared plus b squared equals c squared, which is very familiar, Pythagorean theorem. And there are a couple of altitude to hypotenuse equality. First one is h squared. H is actually right here, so h is the altitude. So if you look at the right angle there, h is right here. All right, h squared is equal to c1. C1 is right here, and the c2 is right there. So from here to there, and from here to there. All right, and h is equal to ab over c. And the other results, a squared over b squared equals c1 over c2. A squared minus b squared is equal to c1 squared minus c2 squared. All right, let's verify all of them. All right, so let's try to establish Pythagorean theorem first. Right, so we're gonna pull out some smaller triangles. Right, so for example, I'm gonna pull out this little triangle and draw it right here. So I'm gonna pull it out and turn it over, so it's gonna look kind of like this. So it's a right triangle, but the smallest one. Right, so right angle here. Right, so this is C1, and that corresponds to H. And that's going to be B right here, right? So using angle, all right, and we're going to pull out this mid-size right triangle. So it's going to be a mid-size and still a right triangle. So it's going to look like that. All right, so you have, let's see, so this is going to be C2. And that's going to be H, and that's going to be A, right? So all three triangles are all similar to each other. You can see that here. This is just using angle. So here, angle, we'll establish that, and which means that this is congruent to that also, right? And this one, so you have that and right angle. So again, this is similar to each other by angle. And these two are similar, angle again, right? So they're all similar to each other, right? So we're going to do the ratio. So once you have similar triangles, all the corresponding sides have the same ratio. So A to, for example, B to H is equal to A to C2 is equal to C to A. Right? Between, oh, so let's see. Oh, actually, I did that on the wrong place. So that will be the similarity between these two guys. So I'll just put it over here. Right? So between these two guys, so B corresponds to C1 is equal to A corresponds to H, right? And C corresponds to B, right? And between these two guys, we can just do H corresponds to C1, and C2 corresponds to H, and A corresponds to B. All right, so let's do that. We want to establish A squared plus B squared is equal to C squared. All right, so maybe I'm gonna focus on, I'm gonna use this guy right here, right? And multiply both sides by A and the C2, we can get this equality. So A squared, it's like a cross multiplication. You're going to get the C times C2, right? And we can get the similar equality looking at, let's see, which one should we look at? B and C, try to find B, oh, here. Let's look at the, oops, this one right here. Right, again, we can do the cross multiplication. That will give you b squared is equal to c1, right? So these two added together, we get a squared plus b squared is equal to c1 plus c2. So factor out c, then you have a c1 plus c2. But the c1 plus c2 is exactly the same thing as c, so you get c times c, so c squared. Right? That is the Pythagorean theorem. So we could verify Pythagorean theorem there. Right? So the next one, h squared equals c1 and c2. All right, so we can find, so is there anything that involves the c1 and c2? How about here? Right, this guy, this is just a cross multiplication will give you h squared is equal to c1 times c2. Right, so that was easy. Right. And the third one, altitude to hypotenuse number 2. All right, so we're looking for C, H, A, B. So which equations are involved in all three? So how about here? If you look at these two guys, right? So we need to get. Let's actually, yeah. So we need to get this guy. So we can just first flip it over, which is going to give you h over b is equal to a over c. Then multiply both sides by b to get h equals ab over c, right? Which is this guy right here, right? Then a squared over b squared, we can use these guys. So we have a squared over b squared is c2 over c1. Actually, I had this backward. Let's see, this was c2 over c1, right? So we can see that we can cancel c's. Then we have c1 over c2, c2 over c1, right? So that will establish this guy, right? Then I think I have this one backward. Also, this is going to be c2 squared minus c1 squared, right? Again, we can just do use these two guys. A squared minus b squared is equal to c2 minus c1, and factor out c, right? c2 minus c1, right? But the c is c1 plus c2 times c2 minus c1. This will give you c2 squared minus c1 squared. Right? So that will give you the last equality. Right? That's it. So all these equality can be proven using three similar triangles. Right? That's it. I hope that this was clear.